Welcome back to MyCodingDays. I'm Mohammed, and in today's video we are going to explore a crucial topic, the lower and upper limits of arithmetic types. If you haven't watched my previous video on arithmetic types in C++, please be sure to check it out as it lays the foundation for this discussion. Now, let's get started. Before we dive into the details, let's clarify what we mean by the bounds or limits of a type. In C++, every type has a range within which its values can be represented accurately. To access these bounds, we will be using the powerful tool called std numeric limits. This template class provides information about the characteristics of various arithmetic types in C++. So let's see it in action. To do that, I'm going to include iostream header file to use the stdcout to print out the results, and I'm also going to include the limits header file. In this header file we have the numeric limits, and we are going to use that. Let me create the main function. To print out the lower and upper limits of a type, such as int, we can follow this approach. So, lower limit of int. So here I'm going to use the numeric limit class. This class is a general templated class. To use a special version of this, we can use angle brackets, and inside this angle bracket we can specify the type that we want to use. So here I'm accessing a special version of numeric limits. In this case it's the int. So inside this class we have several static member functions. One of them is min function. This function returns the lower limit or the minimum possible value that a integer type can hold. Okay, let me put this in new line as well as this one. Okay. We can follow the similar approach to print the upper limit, and here instead of min I should use the max member function, and our main function can return 0 to indicate that our executable file is executed correctly. And let me build and run. Okay, you can see that the lower limit of int is this number and the upper limit of int is this number. We can do the similar approach to find out the lower and upper limits of other arithmetic types, such as double, float, or long int. To save time, I prepared this code to print out the lower and upper bounds of integer types. Here we print out the lower and upper bounds of int. We do the same thing for long int in this section. In the next section we try the unsigned int, and finally we check the lower and upper bound of unsigned long int. Here you see the lower and upper bounds for various integer types. For int you see the lower and upper bounds here. For the long you see the bounds here, and for the unsigned you see the lower and upper bounds here. Is there any relationship between the lower and upper bounds of unsigned int and int, as well as unsigned lang int and signed lang int? I've forgotten to print the unsigned word here. If you found the relationship between these two, please write it in the comment. I have a challenge for you. Can you find out how the lower and upper bounds of integer types are computed? As you may know already, different integer types have different range of values they can represent, like the int and unsigned int have different lower and upper bounds. So your task is to research and find out the exact mechanism behind computing these limits for integer types in C++. And once you have gathered the information, you can share your findings in the comment section below. We encourage you to discuss and collaborate with other fellow viewers to deepen your understanding and help each other to understand these topics better. Thank you. Dealing with the limits of floating point types is a bit different, since with the floating point types, the std numeric limits min function does not return the lower bound. Instead, it returns the smallest positive normalized number, and to get the lower bound we should use another function which is called lowest. So let me show this in action. Lower bound of double is lowest. Let me put this in a new line, as well as this one, and we can compare this with the minimum of double and let me also print out the maximum like this. Let's build and run. Let me clear this. Okay, we can see that the lower bound of double is symmetric with the upper bound. I mean, it is just different in sign, and the minimum function returns the smallest positive value which double can hold. As an exercise, please repeat this on long double and float. Now that we understand the bounds, let's explore what happens when a variable exceeds its limits. In C++, when a variable goes beyond its maximum representable value, we encounter a phenomenon called overflow. Conversely, when a variable goes below its minimum value, we encounter underflow. So to demonstrate this, I'm going to create a variable called maximum int, and I will use the numeric limits class to get the maximum of int, and also I need the minimum of int. I will use numeric limits of int and use the min function, and let's print the value of max int hand, let's add 1 to this max int and print its value to see what's going to happen. Let me duplicate these 2 lines to do something similar with minimum of int. Minimum of int. Let's build. Okay, here we see an interesting result. When I add 1 to the maximum value of int, the result is the same as the minimum value of int. This is called the wraparound behavior. When an arithmetic type reaches its maximum value and goes beyond, it wraps around and continues counting from its minimum value. And this wraparound behavior can lead to unexpected results and require careful attention. So it's very important in our code that we always use the proper data type and we check for its limit, so we won't get overwhelmed with unexpected behaviors and bugs. This brings us to the end of this video. We covered checking the lower and upper bounds of various variable types using std numeric limits. I hope this video was helpful for you, and now before we go, I'd like to remind you to practice what you have learned and experiment with different data types, push the boundaries and observe the results. This hands-on experience will deepen your understanding and make you become a more proficient C++ programmer. And if you have any questions or need any further clarification, feel free to leave a comment below, and I'm always here to help you in your coding journey. Also, don't forget to subscribe to my channel if you haven't already. And thank you for watching and thank you for your support. I appreciate each and every one of you. Keep coding, keep learning, and until the next video, happy coding!